Hi everyone, welcome to the second lesson for topic 4.5 Energy, Work and Power. In previous lesson, we learned about work. So for this lesson, we are going to look at the part for energy. Okay, so there are two types of energy we will be learning today. So the first one is called as gravitational potential energy. In short, we can write it as GPE or sometimes just potential energy, but to be much more precise, then it should be gravitational potential energy. Then the second part is on kinetic energy, so which can be written as KE. So we're going to look at kinetic energy first, then after that, the gravitational potential energy. So we are going to look at what's the definition of these two energy and also to apply the formula for each of them. Okay, so let's start with the lesson. Okay, so previously we learned that in mechanics, work is done by a force when the force causes the object to move. So we know that for us to determine whether there's work done or not, so there are two criteria that we need to fulfill. So the first one is there must be a force that acts on the object. Second thing is the force itself cause the object to move. Okay, and the motion must be obvious, so which means there's distance travel involved. Okay, so the formula of work is given by W equal to F times D, right? Where the F is the force and D is basically the distance traveled by the object when the force is applied. Okay, so for today's lesson, we are going to look at the part for energy. Okay, so when we look at the words kinetic energy, right, you should be able to relate to the words kinematic that we always mentioned previously, right? So when we talk about kinetic energy, it's the same thing where this is the energy that the object possesses because of its motion. Okay, so like kinetic is about motion. So a body of mass mkg moving with speed v meter per second has kinetic energy that's given by ke is equal to half mv squared. So we are going to look at this derivative when we talk about work energy principle, but not now. Okay, so for now, you can just understand it as kinetic energy equals to half mv squared. So what's the unit of energy? Let's find out by using the formula here. So for the mass, what we have kg, right? So v square, so which means it's meter per second and then square. So half is a constant, right? That's not going to give us any unit there. So let's try to expand it. Then we will get kg m squared, then s negative 2. Okay, so now let's try to take out the m so that we will have kg meter second square and then meter. So what do you realize over here is that kg meter per second square, this is the mass and this is the acceleration. So this is ma. So we know that force is equals to ma. Am I right? So what's the unit for force? Is Newton meter. So when we talk about this Newton meter, do you realize that you learned something similar previously? Yeah, it's the same thing with work. You realize that when we try to derive the unit for work, it's also Newton meter. So that's why it's also represented by joules. Okay, so the unit for energy is actually joules, which is the same with work. Okay, so we will understand the relationship between work and energy better when we talk about work energy principle in the next lesson. Okay, and something that you will realize for the formula for kinetic energy is that this is half times the mass times v square, right? So that's why for the v here, actually, there's no direction. I mean, the direction is not important because at the end, you're still going to square it. Then after that, when you times your half and times your mass, it's going to give you a positive answer always. Okay, so yeah, let's talk about the change in kinetic energy. So if there's an object that moves with a initial velocity of u and final velocity of v, the change in the kinetic energy will be equal to the final kinetic energy, right? Then minus of the initial kinetic energy. Okay, so now let's try to do some substitution. So final ke, then the final velocity is v, so that's why it's the same thing, half mv squared. Whereas for the initial kinetic energy, the initial velocity is u, so that's why minus of half u squared, half mu squared. So factorization, so take out a common factor, which is half m. So we have v squared minus u squared. Okay, So the same thing, it doesn't actually matter that much whether there's a change of direction involved or not, because at the end you are still going to square your answer. Okay, but then it's important that you put your final velocity and initial velocity correctly, because that's going to give you your change in kinetic energy can be positive or can be negative. It will be depending on V and U, which one is bigger, right? So if you have a negative answer, then which means that your kinetic energy is losing all the way. So if let's say you have a positive, then which means that that's a gain in the kinetic energy. Okay, so let's try to look at example 1. Okay, find the kinetic energy of a body of mass 3 kg moving at 5 meter per second. So this is a very direct question, so just substitution. So kinetic energy is half mv square. So substitute the mass is 3 kg, then the velocity is 5 square. Okay, so half times 3 times 25, and that gives us 37.5 joule. Okay, so question 2. Okay, number 2, a ball of mass 50 gram hits the ground with speed 10 meter per second and rebounds with speed 6 meter per second. So that's this ball. Okay, so hits the ground with 10, rebounds with 6. So find the loss in kinetic energy that occurs in a bounce. Okay, so we can use the formula. Either you want to do half mv square minus half mu square, or you just want to use the one after factorization, which will be easier. So half m then v square minus u square. Okay, so make sure that you are using the right one for which one is your v and which one is your u. So let's try to find the change first, then after that we only write it in the loss. Okay, so you know that since the question already said that it's the loss in kinetic energy, so which means that your final kinetic energy is actually lesser than the initial one. So your change in Ke should be a negative value, so to prove that you are doing the right thing. So 1 over 2, so the mass here is 0.05. Okay, so v square, although it doesn't matter, but it would be good that you understand that it's in the opposite direction, so that's why your v square is like negative 6 square. Okay, and then minus of u square, which is 10 square. Alright, so now let's try to solve it. So 1 over 2, 0.05. So we have 36 minus 100, which gives us negative 64. So you can see your last answer will be a negative value, which is negative 1.6 joules. Okay, so which means that's a loss. So the loss in Ke will be equal to 1.6 joules. Okay, so you can actually understand this idea as if let's say the final velocity is lesser than the initial velocity, right, then there will be a loss in the kinetic energy. If let's say the final velocity is higher than the initial velocity, then which means there will be a gain in Ke. Okay, so number 3. A body of mass 6 kg increases its energy by 38 joules. So if the initial speed was 2 meter per second, find its final speed. Okay, so in this case, then we know that the change in the energy, right? So in this case, we assume that that's only kinetic energy lah. So the change in kinetic energy is 38. So increases its energy. So that's why the change should be a positive one. Okay, so let's try to write down the formula. So half m v square minus u square is equal to 38. Okay, so let's substitute. So the mass is 6 kg. So we want to find the final velocity, right? So v square then minus of the u square, which is 2 square. Okay, and that gives us 38. So now let's try to solve some max. So we have v square will be equal to, so 38, then multiply 2 divide by 6, and then plus 4 square, then that is going to give us 16.67. Okay, so after we got this, then we solve it and we'll be able to get, yeah, so remember, after you square it, then it will be positive and negative. Okay, so 4.08 meter per second in 3SF. Alright, so yeah, since the question asks for the final speed, so that's why you shouldn't have any positive or negative, because this one we talk about velocity, right? So the final speed, we are just going to take the magnitude, so which is going to be 4.08 meter per second. Okay, so let's move on to number 4. Okay, number 4, a baseball of mass 2 kg is projected upwards with speed 13 meter per second. The catcher catches it after 3 seconds. Find the gain in the kinetic energy in these 3 seconds. Okay, so for this situation, then you realize that you only have the initial velocity, but you doesn't have the final velocity. So we might need to use the Suvat formula to actually help us to do that. Okay, so that's some information that's given. So since it's projected upwards, so we know that the acceleration will be following the gravitational acceleration, right? So yeah, if you were to draw it, then it will be something like this. Okay, so it projected upwards, so with 13 meter per second. Then after that it drops down, so we're not sure where is it, but this is like the person here catches the ball. Okay, so that's the idea. Then the whole process takes 3 seconds. So find again in the kinetic energy. So we know that kinetic energy will need to have the final velocity as well. So we need to use Subat formula. Okay, so U is equal to 13. And we know that the time taken for the whole process is 3 seconds. So we want to find the final velocity, right? A is equal to, so this ball is moving up, so the acceleration is -10, then the velocity is what we want to find. So you should expect that the velocity that you get should be a negative value, because like, I mean, it's possible lah. If let's say this is like projected upwards, then this person actually catch it like at a height here. But I mean, in a sense of logic, then it must be like going down. Then the v that you get is a negative value. Okay, so now let's try to find out. So we have u v, u v a and t. So we can do v equals to u plus a t. So 13 plus -10, the time is 3. Okay, so from here we can get that v is equal to 13 and then minus 30, which is -17 meter per second. Okay, so that's correct. And the ball actually falls below the initial position when it's like 13 meter per second, because at this place it's like -17, right? Okay, so now we have the final velocity already, then we can find our gain. So in this case, we can straight away write the gain because it's just the same thing. I mean, no worry, if let's say you have the loss in KE, right? And what you want to do is, because you know that if let's say it's a loss, then which means that your initial is larger than your final. And if you want to do like the initial kinetic energy minus of your final kinetic energy also can. Okay, so you're depending on how you want to approach it. So half, okay, the mass is 2 kg, then the final velocity -17 square minus of u square, which is 13 square. Okay, so we have half 2, and this is 17, so 289, and 13 is 196, 169. Okay, so let's try to solve this, then we'll be able to get 1 and then 120 joule. Okay, so that's this question. So let's try to look at another one before we move on to gravitational potential. Okay, so this is the question relating the momentum to kinetic energy. Okay, so as you can see, that's like two particles and there's collision that occur. So two particles are moving directly towards each other. So we have particle A, okay, and then let's try to make it slightly bigger. Okay, so we have particle A. Okay, so they are moving towards each other, so which means it's like this. Then we have particle B as well later. Okay, so particle A has a mass of 300 grams, so which is 0.3 kg. So it's moving with a velocity of 2 meter per second. So particle B has a mass of 100 grams, so 0.1 kg. So it's moving at 1 meter per second. Okay, so you remember in momentum, it's very important for us to denote the positive direction and negative direction. Yeah, so in this case, we know that going to this way is in the opposite direction. So we try to assume that going right is our positive. So in this case, then this will be -1. Okay, So after the collision, the particle A is moving with a speed of v meter per second. So we can write in the bottom to indicate that this is after the collision. So we have v, and then this is v plus 2. Okay, so find the loss in kinetic energy in 3SF for the particle A after the collision. So which means in this case, right, we doesn't know that whether this particle, I mean, by looking at V and V plus 2, you know that they are not going to coalesce together. So which means that they are not moving together with the same velocity, because if let's say one is V, then the other one is V plus 2, then obviously their velocity is different, like, right? But we doesn't know that whether they move into a different direction, which means are they moving like this, or they are moving like this, or they are moving like this. So that's the thing that we don't know. Okay, but in this idea, since we already denoted that going to the right as positive, so we will assume that this speed is like a positive one, that we try to assume that it's going this way. Okay, so it doesn't matter much why is that so, because if let's say you are getting a negative v, right, then which means that it's just going to the left lor. Yeah, it doesn't matter like what is the v that you try to put in place, because the v represent the velocity, and from the positive sign or negative sign that after you solve, then you'll be able to see whether it's going to the left or to the right. Okay, so now let's try to solve by using the conservation of momentum. So the momentum before, okay, so the p before, it should be equal to the p after. Okay, so I hope that you still remember momentum is equals to mv, right? So for this case, then we have the mass 0.3 times 2, and then plus particle b 0.1 times negative 1 for the velocity equal to the final. So 0.3 times v, and then plus the other part we have 0.1, and then times v plus 2. So now let's solve the v. So 0.6 minus 0.1 equal to, so after we plus it together, then we have 0.4 v, and then plus 0.2. So when you solve it, then we have 0.4 v equal to 0.3, and divide 3 divided by 4, and that gives us 0.75 meter per second. Okay, so after we got this, so now we can proceed to find the loss in the kinetic energy. So like what I said, yeah, maybe I'll try to show you once here. So if you know that the kinetic energy is a loss one, then you have an alternative that, because if you use final to minus the initial, because the final is lesser than the initial, so that's why you will get a negative value. So if let's say you want to prevent, you want to straight away to get a positive value, loss meaning that initial is greater. So that's why you just use the initial. So it will become like half m, then after that u squared minus v squared. So which means you take the initial to minus the final, because you already know that initial is greater than the final. So equal to half. So the m is 0.3, and then 0.75. Yeah, so since you get a positive answer, so you know that meaning after the collision, both of this particle is moving to the right. Okay, so 0.75, sorry, we should put the initial one first, because we are doing u square minus, so u is 2, u square minus 0.75 square. Okay, so you'll get the exactly same answer in positive. So if you are doing the change, then you'll be getting a negative answer. Then after that, you just change it to positive and indicate that that's the loss. Okay, so that's the idea for it. Okay, so let's look at the second type of energy in our lesson, which is gravitational potential energy. Okay, so gravitational potential energy is an energy that a body possesses because of its position. Okay, so it's different than the kinetic energy that we mentioned just now, that is depending on the motion, which is the speed or the velocity. Okay, but potential energy is based on where it is, so it's just purely on position. So it can be thought of as a stored energy. So which means that it is not an energy that produces by motion. So it's just that if if let's say there's a particle that on a table, so without having any motion, it has its own gravitational potential energy as well. So this energy can be released if the body falls under gravity. Okay, so a body of mass mkg at height of h has gravitational potential energy GPE, which will be given by the mass times the gravitational acceleration times the height. Okay, so which means, and in another words, we know that g is 10, right? So you can always write 10 mh, but it will be good that you just remember mass times g times h. Okay, so in this case, you can see that for the unit part, right, it's going to be the same thing like just now. So we have kg for the mass. So the g is gravitational acceleration, right, which the unit is follow the acceleration, which is meter per second square. Okay, then the height will be meter. So what do you realize here is this is m times a, which is the force, which is Newton meter as well, and Newton meter is just joule. Okay, so the unit for potential energy is also joule. So which means for all the energy, the unit is actually just joule, which is the same with work. Okay, so the amount of potential energy that a body possesses depends on its height. Because when I try to look at the formula, right, mgh, so g is the one that's constant already, which following the 10 meter per second square. Then the mass of a body is something that you can't change, right? So the only thing that decide how much the potential energy is by the height. Okay, so it means for kinetic energy is basically by the velocity. So if let's say the object is moving with a faster speed, then the ke is high. So if lower speed, then the ke is low. So it means by looking at this one, which means that if the height is higher, then after that your GPE is going to be higher as well. If it's at a lower position, which means that the GPE will be lower. Okay, so this height is measured from some base level where the GPE is equal to 0. Later we are going to look at the example to for me to explain further for this part. So we can choose any level as the base, but just remember that for the whole entire question, all your height must be measured from the same base. Okay? So which means that if let's say you have different height, right, then it's your choice to determine which is your base level. But just make sure that when you calculate your height, especially you are finding the change in your potential energy, you must be using the same height. Okay, sorry, you must be using the same base level. Okay, so for an object moving with an initial height of h1 and final height of h2, the change in potential energy will be equal to, yeah, so the same thing, the final GPE, then be minus off the initial GPE, right? So in this case, what we have is going to be equal to mgh2 minus of mgh1. So factorization, we can take out m and g. So inside our bracket, we have h2 minus h1. So something that I just wish to mention beforehand is that your height can be a negative height. So later, when we try to determine the base level, then I'll try to explain further for this. So now let's try to look at the first example for GPE. Okay, so I'm going to use this example to explain about the base level that we mentioned just now. Okay, so a ball of 2 kg is projected vertically upwards from a tabletop which is 4 meters above the ground. Okay, so if let's say this is our ground, so which means I have the table, so which is 4 meters above the ground. So this ball is projected vertical upwards from this surface of the tabletop, right? So find the gravitational potential energy when the ball is 3 meters above the tabletop. So which means maybe the ball now is here. Okay, so it's 3 meters above the tabletop. Okay, so you can see that there are actually three level involved in this question. So the first one is the maximum height here. The second one is the surface for tabletop, and the last one is the ground. Okay, So let's try to see, is there any difference when you take different level to become your base level? Okay, so let's try to look at the first one. If let's say normally the easiest one that we can do is using the ground. So by using the ground as base level, so what you can see is that our base level is like the place where the height is 0. So that's why at this place, when you try to find the MGH, the height is 0. So the PE here is 0. Okay. So which means that in another words, so what's the height over here? It's going to be 4 meter above the ground, right? So what is the position here? It's going to be 7 meter above the ground. So when we try to use the ground as the base level, then our change in the GPE will be equal to, let's try to use the normal one for this question. So MGH1. So you'll realize that we will have 2 kg and G is 10. So what is the height to the final height? Is 7 meter from the ground, right? So that's why 7. Then minus of 210. So the initial height is 4 meter above the ground, so 4. So what we have here is 140 minus 80, and that gives us 60 joules. Okay, so now let's try to find out if let's say we try to use the other. So which means, for example, let's try to use the base here. Okay, we try to use the tabletop as the base. Okay, so same thing. We try to find the change in the GPE as well. And by using the exact same formula. Okay, but now if let's say the tabletop is your base level, right, then what is your final height now? So which means this is the place where the height is 0, which the potential energy is 0. So what is the height for your final position when your ball is here? It's going to be 3, am I right? So that's why it's 2, 10, and then times 3. So when you minus off the initial, so this is the place where the ball is at initial, right? And this is the level where you decide to be as the base level. So that's why at this place, your height is just 0. So 2, 10, and 0. So what you realize here is that you are going to get 0 for this part. So 2 times 10 times 3, that's going to give you the exact same answer like the previous one, which is 60 joule as well. Okay, so last but not least, let's try to do, let's say the highest point. Okay, so let me try to use the other color. So this is like the highest part here. Okay, but I mean, normally you don't, I mean, you can, I just want to show you that you can't do that, but you can do that, but in form of like the logic of itself, you doesn't want to deal with like negative height and so on. So that's why I will actually much more encourage you to use this too. Okay, but just to show you that it's actually the same thing. So use the highest point as the base level. Okay, so what you can realize here is that we just use the same thing here. So the change in GPE is equal to MGH2 minus MGH1. Okay, so if let's say your base level is here, right, then what is the height for your final? It's going to be at your base level, right? So that's why the H2 here is 0. So 2, 10 times 0. Okay, so now is the second part. So it's going to be 210. But what is the initial height? It's going to be lower than your base level. Am I right? If let's say it's lower than your base area, your base level, then which means that it's going to give you a negative height. So in this case, it's negative 3. So what do you realize here is 0 minus negative 60, and that gives you 60 joule as well. Okay, so this is the idea where you can choose any base level and at the end you will get the same answer. But just to make sure that if you already choose tabletop as the base level, then your H2 and your H1 must be based on the base level of tabletop. So you can't H2 suddenly use tabletop, then suddenly H1 you use the ground. So that's the idea. You must use the same base level for the entire question after you have decided. Okay, but like what I said, normally we will love to I mean deal with like a positive height rather than negative height. So I'll actually encourage you to go with the first two approach rather than the last one. Okay, so now let's move on to question 7. Okay, so 7 and 8 is a very direct question. So why am I putting it in is to explain a little bit about the relationship for the energy and also for the work done, so that you have some idea before we move on to the next lesson, which we discuss about the work energy principle. Okay, so the climber of mass 75 kg scales a mountain 1.8 km height. So in other words, it's 1,800 meter. Okay, so find the gain in potential energy. So it'll be easier that we just set the ground as the base level, which at this point the GPE is equal to 0. Okay, so the change in the potential energy will be equal to, let's write GPE instead. Okay, so mg, then the final height minus the initial height. So we have 75 times 10, and the final height is 1,800 minus of the initial height is 0. So from here, then we are able to get 1350 and 000 joule. Okay, so or you can write like 1,350 kilojoule as well. Okay, so now let's try to see if, let's say I try to change this question to find out the work done. Okay, then what you will be doing. So the work done by the force here is what is the force that actually acts on this person is the weight, am I right? So that's why when this person is actually raised up, so which means that it's going against the gravitational acceleration. So we know that this work done is actually done by the weight but in opposite direction, which means it's the work done against the gravity. So that's why it will move up, am I right? So that's why this is supposed to be the work done against the gravity because it's moving up. Then how are we going to find that is force multiplied S? Am I right? So what is our force here, which is the weight, right? So that's why the weight of this climber is actually 750 Newton. So what is the displacement? Is 1,800. So that's why you see that the answer that you get at the end is exactly the same thing like what you found in the change in potential energy. So that's why you can understand it as if energy and work done is like it's like you're having a coin. Then no matter you're having the front side or the back side is just the same coin, but then you're just looking at it in a different situation. So yeah, that's why they are actually related. So that's why they can like share the same unit, right? So in the next lesson, we are going to talk about this in much more detail. So it's the same thing for number 8. Let's try to look at it. Okay, number 8, the carriage on a roller coaster ride has a mass of 130 kg. So find a change in potential energy when the carriage actually descend for 12 meter. Okay, so depends on you whether you want to put the original position as 0, then your ground below it as negative 12, or you just want to do, let me write down two approaches. So first one is you just want this to be your 0, then this place is your negative 12. Then the other approach that you can try to take is this place is your 12 and this place is your 0. So you're just going to get the same answer. So don't worry about that. So the change in potential energy will be equal to same thing, mgh2 minus h1. So if you are using the first one, then you will be getting your m is 130 g. Okay, and then the final position here, the final height is at negative 12. Okay, and then minus of the initial, which is 0. Okay, so sorry, no square here. So, or the other case, if let's say you are following the second case, then what you get is 130 times g. So this is your final position, right? So that's why it's 0. Then you're going to minus 12. Okay, so you see, no matter which approach that you are doing, you're still getting negative 12 in this bracket. So negative 12 minus 0 or 0 minus 12 is just going to give you the same answer, which is negative 12. So when you try to solve it, then you are able to get your answer as negative 15600 joule. Okay, so you can see it's a negative because the position actually moved from a higher height to a lower height. So that's why it's a loss lah. Or if let's say you want to write it in the loss, then it will be it's a loss in PE, then it will be equal to positive 15600 joule. Okay, so the same thing you see, this carriage actually descend for 12 meter. So if let's say if we talk about work done, then what is this work done by the force? So what is the force that actually causes this work done? It's by the weight, right? So which is the work done by the gravity. So you can see if we try to carry out F times S, it's going to give us the same thing, which is 1300, then the displacement is 12. So from here, then you are going to get 15600 joule as well. Okay, then of course, you will realize that the number is the same. In another way, right, you can just understand it from the formula as well, because we talk about PE is like mgh, and we talk about the work done is Fs. Okay, so what do you realize here is especially okay, we can't explain this for kinetic energy because we don't have the same term. So the force that you apply here, we can't see it from the velocity. But in this case, you realize that for the F times S, right? If let's say the force is actually caused by the gravity, then which means in this case, the F here is actually our W. So that's why what is our W is actually mg. So that's why that is why that causes you to have the same answer. Okay, so that's the idea of it. So I just want you to have this brief idea that they are actually the referring to the same idea, but it's just that we are trying to look at it in a different scenario. So for the next session, we are going to understand this in further. So now let's try to look at the last two questions, which will look at the situation where if let's say it's not a vertical distance, but the particle is actually on a slope. Okay, so number 9. Okay, a block of mass 2.9 kg slides down the line of the greatest slope of a rough inclined plane. So let's try to draw the plane first. Okay, so this is what we have. Then that's a block, right? Is 2.9 kg, so which means the weight is 29 Newton. The normal reaction between the block and the plane is 21 Newton, so which means here is 21. Okay, so we can extend it. Yeah, so show that if the angle of the slope of the plane is theta, so show that cos theta is 21 over 29. So in this case, this is theta. Okay, so by using the idea of angle, then we know that this is theta as well. So I hope that you are very familiar with this idea already. So just by looking at the picture, then you know that the theta is placed at where. Okay, so since we know that this block is going to slide down, right? So that's why the vertical component, which means the component that's perpendicular to the surface, should be in equilibrium. So in another words, the normal reaction is actually equal to the resolved component for the weight here. So 29 cos theta, right? So that's why the question already gives us that the normal reaction is 21, so equal to 29 cos theta, and that's how we get the part 1, which cos theta is equal to 21 over 29. Okay, so as simple as that. Okay, B, calculate the change in gravitational potential energy if the block slides a distance of 2.4 meter. So which means the distance taken here. So we're not sure whether the length is 2.4 or not, but we know that the block is slides a distance of 2.4 meter. Okay, so now we need to find the change in the gravitational potential energy. So you must remember that when we talk about the change in GPE, right, the distance that we must be using for the height, it must be a vertical distance. So which means that when you try to look at it, then it must be, if let's say until 2.5 is at this place lah. Okay, so which means that we need to get what is the distance of the height here. It's not the slanted distance. Okay, so in this case, which means that we need to find out what is the height when it actually, I mean, what's the vertical height so that we can try to find out the GPE. So now let's try to draw it. So we already know that cos theta is 21 over 29, right? So in another words, we can find out the other side. So cos theta is 21 over this one, no need to write, it's okay. So by having this picture, and we know that if the theta is here, then this is the place for 21 and this is 29. So we can actually find the other side, which is the opposite. It will be equal to 29 square minus 21 square, right? And that gives us an exact value, which is 20. So we know that sine theta is actually equal to 20 over 29. Okay, so now remember, we are not saying that the slanted distance for the from the top to the bottom is 2.4. We just know that it slides for a distance for 2.4. But that doesn't matter, right? Because no matter where are you sliding, okay, imagine this is your slanted plane. Okay, so this is your theta, right? So no matter where is your 2.4, it's still going to follow the same triangle, if you get what I mean. So if let's say this is my right angle triangle and this whole thing is I mean in the cos of 21 over 29 and sine 20 over 29, just going to give me the same thing because this is going to be my theta, this is going to be my theta all the way. So it's just that based on what's the value here, I'm going to get a different value for my h. Okay, so that's why I can straight away use this idea to find out what is the vertical height. So in simple words, let's try to just use this. Okay, so if let's say this is 2.4, which means 2.4 represent like the 29 here. So we can try to find out. So sine theta is equal to 20 over 29, right? So the sine here is OH. So this is what we want to find, which is the height. Then over 2.4 is equal to 20 over 29. So that actually gives us that H is equal to 20 over 29 times 2.4. Okay, so now we can try to find out the change in GPE already. So change in GPE, it will be equal to the final. So mg, so you know that it slides down, so which means it's going to be a loss lah, than h2 minus h1. Okay, so the mass here is 22.9, gravitational acceleration 10. So final, let's try to put the final as the, I mean the final is at the ground. So I mean it's not at the ground, it's your final position as your base level. So that's why that's 0. So the h is what we have here. So we just substitute the whole thing, 20 over 29 and then times 2.4. Okay, so by solving this, then you'll be able to get a negative answer, which is negative 48 joule. Okay, so that's the change in GPE, and we just change it to the loss. So the loss in GPE is equal to 48 joule. Okay, so that's the answer for this part. So I hope that you can get the idea. So now let's look at the last example. Okay, 10. A ram rises 10 cm for every 80 cm along the sloping surface. So yeah, so this is a question that's similar to number 9 just now, which they didn't actually give you the exact height. But the idea is that, you know, so for example, if let's say every 80 cm, then that's going to rise like 10. So meaning if let's say this is 80, then this is going to be 10. If I extend another 80, then this is going to be like 10 plus 10. You get what I mean, right? So like a triangle is a fixed one. Okay, so a box of, so we can try to draw that. Okay, so a box of mass 50 kg, so which is 500 Newton for the weight, slides down the ramp resting starting from rest at the top of the ramp. So the coefficient of friction between the ramp and the box is 0.03. So that's why for this question there's friction involved. So since the motion is sloping down, so that's why the friction is going up lah. Okay, so there's no other resistance force, so that's why this will be the case. So R, and then we have this. Okay, So the box is traveling at 2 meter per second when it reaches the bottom of the ramp. And the question wants us to find the length of the ramp. Okay, so in this case, there's nothing about GPE. First is just like force that you learned previously, and force and suvat. Okay, so in this case, then we might need to find out what is our theta here. Okay, so for us to do that, then is by using this idea. So you can imagine the ramp actually rises 10 cm for every 80 cm along the sloping surface. So which means when we try to look at the theta, right, it will just following the ratio of 10 and then 80. So that's why this can help us to solve the sine. So sine theta, it will be equal to OH, right? So 10 over 80, which gives us 1 over 8. So depending on you whether you want to solve the theta or not, okay? Or you just want to keep the sine ratio, then you are just going to use like hypotenuse to solve it, okay? Or you can just store your value in your calculator, and I guess that will be much more easier. So the theta here will be equal to, so we can shift sine 10 over 80, and that's going to give us 7.18. So remember to store this value in your calculator, yeah, so later when you need the costing, then it's easier for you. Okay, so now let's move on. So after we get the theta here, so we can try to solve, we need to find the net force equals to ma so that we know the acceleration, right? Then by using suvat, then only you can find the length. So if let's say we need to find the net force, then which means we need to find the friction. So if let's say we need to find the friction, we need the normal reaction first. So the normal reaction will be equal to the weight and then cos theta. Okay, so we have 500 and then cos 7.18. So remember to take the full value here. So from here, you will be able to get 496.08 Newton. So after we have got this, then now we can proceed with F equals to ma, right? So in this case, the net force, it will be equal to, in this direction, we have the resolving component from the weight as well. Don't forget this. So we have 500 sine theta minus of friction in another direction, right? Okay, let us try to write the full one for the first line. Okay, so we have the weight sine theta minus of the friction, then equal to ma. Okay, so the weight is 500, then sine theta is 1 over 8. If you want to use sine 7.1, it also can. Doesn't matter, you will just get the same answer. So mu r 0.03 times the r just now. Remember to store this value as well, equal to the mass, which is 50 kg, then acceleration. Okay, so from here, you'll be able to get your A is equal to 0.9524 meter per second square. Okay, so after you got this, then now we can do suvat, right? So to solve your S, so u v squared equal to u squared plus 2as. Sorry, can we write down here? So I scared that I don't have a space later. Okay, maybe I should actually, before I send to you, I would make it into like 2 pages lah. Yeah, I think my handwriting is a bit small when I'm writing my draft, so I got enough space there. Okay, so let's try to continue here. Sorry for that, just to keep it a little bit more tidy. Okay, so start from rest. So when it reaches the bottom, the V is 2, and we already got the A just now, right? So we want to find the S. So V squared equal to U squared plus 2AS. So we have 2 squared minus equal to 0 squared plus 2A and then S. Okay, so just use your calculator to solve it, then you'll be able to get S equal to 2.10 meter. Okay, so that's the length of the ramp. Okay, so now let's try to solve for part B. Okay, so in this case, which means that you already know that what's the slope for the ramp here, the length of the ramp, which is 2.10. Okay, and you also have the theta already. So which means now we can find out what is the height here. Okay, so just by using sine as well, so sine theta is equal 1 over 8. Okay, so OH, so height is the opposite, then over 2.10 for the hypotenuse is 1 over 8. So the height is just 1 over 8 times 2.10. Okay, so yeah, depending on you whether you want to finish the working or not. I think in this case we can, it's not, I mean the number is still okay. So 0.2625. Okay, so the question one is to find the loss in the GPE. So you can use the initial to minus the final. So we can do half m, then u square minus v square. Okay, so oops. So since we want to find the loss, so we can try to use the initial to minus the final, which is mg, then h1 minus h2. Okay, so let's try to take the initial as this part lah. Then after that, this is our final, right? So this is our base level, then which means this is 0 and this is going to be negative 0.2625. So it's the same thing if you want to, I mean, I doesn't need to explain this again, right? If you were to take this as ground, then this will be 0.2625. Okay, so depending on you. So in this case, our mass for this object is 50. So G is 10. Okay, so the initial is 0. Then we do negative 0.2625. Okay, and you'll be able to straight away get a positive value for your loss. So it's going to be 131 joule in 3SF. Okay, so that's the idea for this question. So I hope that you can understand like how do you find slope. So the idea is that make sure that the height that you are using, it must be a vertical one. It cannot be a slanted one. So you need to get the information. Then after that, you find out what's your vertical height. Okay, so spend some time to do the homework, and that's pretty much for today's lesson. Thank you.